Hello again. This is part 3 of our discussion on measurements and vectors. In this video, we will start with the analytical method of adding vectors, and then we will get to learn two ways of multiplying vectors. So consider a two-dimensional vector, say for example vector r. Vector r has x and y components. We can resolve vector r into its x and y components. The x component of r is the projection of r along the x-axis. We can call it r sub x. Likewise, the y component of r is the projection of r in the y-axis. We will call it r sub y. These components are also vectors with magnitude that can be obtained using simple trigonometry. Suppose we are given only with the magnitude and direction of vector r. How can we know the magnitude of r sub x and r sub y? Notice that when we transfer r sub y here, we can form a right triangle. When we have a right triangle, the length of the two sides and the hypotenuse are related using the Pythagorean theorem. So if you can recall, if C is the hypotenuse and A and B are the two sides, then C squared equals A squared plus B squared. So in this figure, we can see that the magnitude of vector r is the hypotenuse, and r sub x and r sub y are the two sides. And if we let theta be the angle between r and r sub x, then we can also use the trigonometric equations to find the magnitudes of vectors r sub x and r sub y. Therefore, using the Pythagorean theorem, we have now this relationship. So we have the magnitude of r squared is equal to the magnitude of r sub x squared plus the magnitude of r sub y squared. And then using the trigonometric equations, so katowa, we have ka. This means that cosine theta is equal to the side adjacent over the hypotenuse. So here we can see that the side adjacent to angle theta is r sub x. So we have cosine theta is equal to r sub x over r. And if we're going to manipulate this equation, we can get r sub x equals r multiplied by cosine theta. And then we also have so we have sine theta is equal to the side opposite to angle theta, which is r sub y, over the hypotenuse. So we have this equation. Sine theta equals r sub y over r. And from this equation, we can get r sub y. So we have r sub y is equal to r multiplied by sine theta. And lastly, we have TOA. This means that tangent theta is equal to the side opposite, which is r sub y, and divided by the side adjacent, which is r sub x. So we have tangent theta is equal to r sub y over r sub x. Now, the previous equations are always true if theta is measured counterclockwise with respect to the positive x-axis. The components can be positive or negative and will have the same units as the original vector. Consider this vector, vector A. This vector is positioned along the positive x-axis. Therefore, theta is equal to 0. The x component of this vector is just equal to the magnitude of vector A, and the y component is obviously 0. So it has no projection along the y-axis. So this is the case wherein theta equals 45 degrees, meaning to say it is midway between the positive x-axis and the positive y-axis. So in here, a sub x can be obtained using this equation. We have a cosine 45 degrees, and a sub y is equal to a sine 45 degrees. And if your vector A is positioned here, that means theta equals 90 degrees. So take note that theta is measured from the positive x-axis towards your vector. So we have a sub x is equal to 0 and a sub y is just equal to a, the magnitude of vector A. And then this is the case wherein theta equals 135 degrees. So a sub x is equal to a cosine 135 degrees. And then a sub y equals a sine 135 degrees. So here, theta is equal to 180 degrees. So a sub x is equal to the negative of the magnitude of vector A, and a sub y is equal to 0. And then we have theta is equal to 225 degrees. So in here, we can see that a sub x equals a cosine 225 degrees, and a sub y equals a sine 225 degrees. And then here, we have theta equals 270 degrees. A sub x equals 0, and then a sub y is equal to the negative of the magnitude of a. And then here we have theta equals 315 degrees, wherein a sub x equals a cosine 315 degrees, and then a sub y equals a sine 315 degrees. Okay, so notice that in the first quadrant, so first quadrant means theta equals 0 to 90 degrees. Both the x and y components of your vector are positive. And in the second quadrant, so here from 90 degrees to 180 degrees, the x component is negative and the y component is positive. In the third quadrant, we have both the x and y components negative. And then in the fourth quadrant, the x component is positive, but the y component is negative. So take note that given the x and y components, we can get the magnitude of a vector using the Pythagorean theorem. So we have r is equal to the square root of r sub x squared plus r sub y squared. And the direction can be obtained using the following equations. So we have tangent inverse of r sub x over r sub y, or we have theta equals the r cosine of r sub x over r, and theta is equal to sine inverse of r sub y over r. And if the magnitude and direction of a vector are given, then we can get the x and y components using these equations. We have r sub x equals r cosine theta, and r sub y is equal to r sine theta. Now that we know how to resolve vectors into its x and y components, now let us now add vectors using the component method. So for example, if we are given with two vectors, we first resolve each vectors into components. For example, we have vector A, which is equal to 24 kilometers, directed 30 degrees counterclockwise from the positive x-axis. And we have vector B, which is 24 kilometers, 30 degrees north of east. So we have to resolve each of these vectors into its components. So this means that we should get the x and y components of this vector. So vector A, we have a sub x is equal to a cosine theta. Now we are given with this direction, 30 degrees clockwise from the positive x-axis. So this means Our angle theta is 330 degrees. Simple calculation will give us 20.8 kilometers. And then we can get a sub y, the y component of vector A, by using this equation. We have a sine theta. Again, the angle that we will be using is the angle that is measured counterclockwise from the positive x-axis. So we have 330 degrees. So 24 sine 330 degrees, this is equivalent to negative 12 kilometers. Okay, so you have a positive x component and a negative y component. Therefore, this vector is situated or located in the fourth quadrant. Okay, vector b, you have b sub x is equal to b cosine theta. So our theta here, we are given with the direction 30 degrees north of east. So this means that from the east, we measure 30 degrees going to the north. East is in the positive x-axis. So 30 degrees north of east is 30 degrees counterclockwise from the positive x-axis. So we have here 24 kilometers cosine 30 degrees, which is equivalent to 20.8 kilometers. And then we have the y component of b, which is equal to b sine theta. We have 24 sine 30 degrees, which is equal to 12 kilometers. So both the x and y components of b are positive. It is in the first quadrant. Now the second step is to add all the x components and add all the y components. So the resultant vector, its x component r sub x is equal to a sub x plus b sub x. So we just have to add all the x components. That is 20.8 kilometers plus 20.8 kilometers. We have 41.6 kilometers. And adding all the y components, we have r sub y equals a sub y plus b sub y, which is equal to minus 12 kilometers plus 12 kilometers. We will get 0 kilometer. Okay, and then the third step is to find the magnitude of the resultant vector using the Pythagorean theorem. So here we have r equals the square root of r sub x squared plus r sub y squared. So this is equivalent to substitute the values of r sub x and r sub y, and we will get 41.6 kilometers. So this is now the magnitude of the resultant vector. By the way, the resultant vector is the sum of two or more vectors. And then the direction can be obtained using, for example, we can use this cosine theta equals r sub x over r, or theta is equal to the arc cosine or the inverse cosine of r sub x over r. So we have 0. Cosine inverse of 1 is equal to 0. So we can see here that the resultant vector is 41.6 kilometers and is directed along the positive x-axis since we have theta is equal to 0. We also introduced unit vectors, which is a vector that has a magnitude of 1 with no units. Its only purpose is to point, that is, to describe a direction in space. So for example, we can define a unit vector in the positive x-axis. We have I hat, so it has a magnitude of 1 with no units, and it is directed in the positive x-axis. We also have j hat, which is a unit vector in the direction along the positive x-axis, and We have k hat, which is a unit vector that is directed along the positive z-axis. So a vector with components a sub x and a sub y that can be written as we have here this one a equals a sub x plus a sub y. This can be written in terms of the unit vector. So we have a can now be expressed as a sub x I hat plus a sub y j hat. So a sub x I hat here is just the vector a sub x, and a sub y j hat is the vector a sub y. Consider two vectors, vector A, which is equal to a sub x I hat plus a sub y j hat, and vector B, which is equal to b sub x I hat plus b sub y j hat. Then if we add these two vectors, we will have this one, this expression, uh, a sub x plus b sub x I hat plus a sub y plus b sub y j hat. So this means that if C is the resultant vector, C equals A plus B, then C sub x, or the x component of the resultant, is just equal to A sub x plus B sub x, and the y component of the resultant vector C is equal to A sub y plus B sub y. Now here's an example. Vector A is described algebraically as this ordered pair, while vector B is this one. Find the value of the magnitude and direction of the sum C of the vectors A and B. So vector A can be written as this one. We have negative 3 I hat plus 5 j hat. So note that this one here is the x component of vector A, and 5 is the y component of vector A. Likewise, vector B can be written as 4 I hat minus 2 j hat, noting that 4 is the x component of vector B, and negative 2 is the y component of vector B. Now to get the resultant vector, we just have to add all the x components and add all the y components. So we have minus 3 plus 4 I hat plus 5 minus 2 j hat. So we will get 1 I hat plus 3 j hat. So notice here that c sub x is equal to 1 and c sub y is equal to 3. To get the magnitude of vector c, we have to use the Pythagorean theorem. So we have c sub x squared plus c sub y squared, and then get the square root. So you have a 1/2 power here. So that we have 1 squared plus 3 squared. So that is 1 plus 9. So that is 10. And then get the square root of 10, you have 3.16. And the direction, we can use this equation. Theta equals tangent inverse of cy over cx. So we get 71.56 degrees. Or we can actually express our vector c. Vector c can be written as I hat plus 3 j hat. So here is the graphical representation of a resultant vector. So this is vector A, this is vector B. Vector A is in the second quadrant, vector B is in the fourth quadrant, and our resultant vector is in the first quadrant. 71.56 degrees counterclockwise from the positive x-axis. Now here is another exercise for us to work on. Draw these vectors in the Cartesian coordinate plane. So we have 5 vectors. Let's start with vector A. So vector A equals 3 I hat plus 2 j hat. This means that vector A has an x component that is exactly 3 units from the origin. And it also has a y component that is exactly 2 units from the origin. So vector A is located in the first quadrant. Now vector B is equal to 3 units southwest. So when we say southwest, this is midway between the south and the west direction, meaning to say 45 degrees from the west going to the south and 45 degrees from the south going to the west. So we draw a vector that has a length of exactly 3 units midway between the negative x-axis and the negative y-axis. So we have vector v here. It is in the third quadrant. Take note that when using northeast, northwest, southeast, and southwest, that means the vector is located midway between the axis. So for example, northeast, that means the vector is directed midway between the positive x-axis and the positive y-axis. And then vector C is 2 units, 50 degrees north of west. So when we say 50 degrees north of west, we measure a 50-degree angle from the west going to the north. So from here, we measure a 50-degree angle going to the north. So here is our vector C, which has length equal to exactly 2 units. Okay, and then we have vector D, which has magnitude equal to 6 units and is directed 70 degrees counterclockwise from the positive x-axis. So when we say counterclockwise from the positive x-axis, we measure this angle from the east, from here. So we measure a 70-degree angle going to the north or counterclockwise. That means our vector D is located here, 70 degrees from the positive x-axis and has length equal to 6 units. Okay, and lastly we have vector E. So vector E has magnitude equal to 4 units and is directed south. So uh, south is directly 270 degrees from the positive x-axis. So we have this vector E, 4 units, 1, 2, 3, 4, and is directed directly downward. So please take note of the directions of the vector. So we can also have clockwise from the positive x-axis, meaning to say you have to measure it from the positive x-axis and then going clockwise. And for example, you have 30 degrees west of north. That means you have to measure from the north going to the west. 30 degrees from the north going to the west. Now, this is your assignment. So you have to find the resultant vector using the analytical or the component method. So you have to add all of the vectors A, B, C, D, and E. See you in the next video.